Okay, yeah, so I mentioned this already now multiple times. Now it's finally time to have a bit of closer look what these guidelines that you hopefully now all already at least briefly read, what should they mean. And this is this preECO project. So I start a bit with the background information to explain you the background, and then with the problems that we're facing right now, and then in the end, what we want from you. So let's go step by step. So just to explain you this once. So what is preECO actually? So there was this software call by DFG on, the call was research software, quality assured and reusable. And it specifically asked for projects to increase the usability of existing research software. So we were very happy when we saw the call because we exactly knew what we wanted to write about. And we were also very happy, so we were successful. And this is a big thing. The project that we applied for and we got is called preECO, and the long title is a community-driven ecosystem of adapters and application cases for the coupling library precise. It's something that we can really work with. So it's for 3 years. We have 2 positions, and and the goal of the project is to do something for you. So we want to include you from the very beginning, so that you can also steer what we do in this project. And we started this year, and this will run probably till 27. So in the title already there's this word ecosystem. So maybe just as a recap, what do we mean by ecosystem? So ecosystem is all the different software packages, repositories that are around Precise. So 2 visualizations that we use a lot. So the one is Precise in the middle, and then we have this onion. So we have different layers of other software packages that depend on Precise. So for example, the adapters and the tutorials. So each circle here is a different repository, right? And if you look at it from a different angle, you can look at the dependencies, and then you can draw such a dependency graph. So for example, if for a certain tutorial, which is like available in the virtual machine, you need the OpenFOAM adapter, but you also need the Phoenix adapter. The Phoenix adapter needs the Python bindings, and both need the Precise library. Okay, so you see that all of these components, they are connected, and this. So in a way, this was very powerful for a long time. We could split up these concerns and work on these projects individually, but we also need to be sure that they well work together. And now I'm going to tell you about a few problems that we are facing, and we collected them in 2 categories, and these categories will go throughout the presentation. So one category is about adapters, and the other category is about tutorials, whereas we will call them application cases. I tell you in a minute why this is a bit broader than tutorials. Okay, but let's start with adapters. So what kind of problems do we face today? So we have kind of an uncontrolled growth of adapters in the community. So growth is very nice, but it becomes harder and harder to maintain all the adapters, already those that are under the Precise organization, but also what adapters are actually around and in what status they are, right? So just think about the presentations we heard this morning. So you learned about an adapter for QoS, for ISSM, for WRF, for Gizmo, and then for forgot the name, the fire code. So this already 5 adapters, right? But where are these adapters? How could we use them? So I think the questions are clear. Who maintains the adapters? Are they maintained? Okay, so for these now it's clear, but let's move 3 years forward and look back. Are all of these adapters still maintained? And with which precise version did they work? Yeah. And then they all use different software designs. So very common is, so sometimes the adapter is a library. So for the OpenFOAM adapter, sometimes it's just a patch that you patch on top of your code. Sometimes it's fully integrated, like so the code and the adapter is like in one repository. Sometimes it's also just like a collection of examples that you can use. Yeah, a problem, they all have some kind of a configuration because you need to say what is the mesh name. You can either hard code this or you do a configuration. And all of us, we are configuring the same thing, but in a different way. So this is also kind of bad if you want to like, yeah, make this more interoperable. And yeah, how do we document actually what precise features are supported by an adapter? Can you do implicit coupling? Can you do nearest projection mapping with this adapter? So sometimes this is documented, sometimes not. But if it's documented, everybody documents it in a different way. Okay, so, and many, many more problems. I think you get the gist of it, what kind of problems you're facing and what we could do to make this better. So that's adapters, that's the one side. Let's look at application cases. So what is an application case? That is, yeah, some case that you run with precise. So typically there's a precise config somewhere, and there are different adapter configs, and there's some meshes maybe. And typically, yeah, if you're a good sport already, if you write a publication, you also do a data publication. So for example, this is one that, yeah, Kame and David did recently for a paper that we wrote. So we put this here on Dairos, that is our data repository, but you could also put this on Zenodo or in any other system. And then basically you have all of the data is in there, and if everything works well, this could already be reproducible. Okay, so I think this is already very far-fetched. But even if it's reproducible, we still have many problems. And yeah, I just wanted to underline here again that such an application case can have many different purposes. So it could be that you want to, like I think most of you do, you want to study an application-based research question. And that's why you wrote a paper. That's why you have an application case. But it could also be that you're developing coupling methods and you just want to test your coupling method with some case. It could be that you just use such an application case for regression testing, that everything still works, or like in our tutorials or in our course, these are just there to learn how precise works. Okay, so now let's look at the problems. So for many of the cases, whenever we see a paper where somebody used precise, and then yeah, we read it, and then at some point, okay, we don't understand what they mean here. And it would, for us, it would be so much easier if we only could look at the precise config file. Like for all of the presentations this morning, multiple occasions I had the feeling, okay, I don't understand this. Can I look at the precise config file? Then I understand what you did here. So this already would be very easy, right? If you write a publication, there's some way that we can look at the config file. Another problem is, okay, we are developing precise. We are developing features like towards your needs. So the workshop is always a very nice occasion for us. So after the workshop, we have a list of new features that we need. And then we develop them, and at some point we want to test them, but then we have no cases to test them. Right, we only have our small tutorials, but we cannot really test them if we write publications with our tutorials. It also looks a bit silly. So for us, it would be really nice if we could just take any of your cases and run them again with a newer precise version and see now, does it run faster, for example. Okay. Yeah. And even if you did such a data publication, that's very nice. it's not always easy to run. Sometimes in the paper that you write, you give maybe, okay, I used precise 2.5, but you do not say which version of the OpenForm adapter you used, right? So, and you really need all of these versions to make something reproducible. And then maybe all of these are published somewhere, and we remember, there was this one case, and then we don't find it again. So there's currently no overview of all the cases that are already published. Yeah, quite obvious. And then if we use such a case, okay, we want to cite it as well. So how could we cite a case? How could we extend it? Yeah, and many, many more problems. Okay, so we start with the problems. So now let's slowly go towards the solution. So in this project, what do we want to do? We want to improve the fairness of adapters and application cases. We want to enable the community. We want to enable you better for adapter development. And we want to make application cases reproducible. And how? So 3 things that we want to do. Point number 1 is we want to design and implement standardization and quality control of adapter and application case development, together with the community. So this is mainly what I'm going to talk about. So we want to define some standards together and then somehow agree all together, okay, let's now follow these standards, because then everybody benefits. But there is more in the project that we're going to do. We're also going to write many small tools that you can use that should simplify adapter and application case development via automation. So for example, we want to develop tools that you can use to generate precise-config files, and also more powerful checkers of precise-config files that directly tell you what you did wrong. And last, we want to extend our course and disseminate good practices via community training. So for example, we want to develop some best practices on how you could design an adapter, and then teach you this also in the course. All right. So we have to talk about standardization. So what is standardization? So very simple, silly example, right? Standardization is that we define once and for all that whether we're gonna call a velocity field velocity with an uppercase V, or a velocity with a lowercase v, or we call it velocities, or we just call it u. So let's define this all together at some point, write this up, and then in every precise config that you use the standard name. Okay. So of course this is a bit boring, but it is useful. I want to convince you that this is useful, and it has value in itself, right? It's not that this one here is correct and this one is wrong, or this one here is correct and this one is wrong. We just have to define like one thing at the point, and then we follow this, not because it is better, but because it has value in itself, that we only follow one definition. Okay, yes, and so the idea would be that we want to write these up, and we want to write them up in this guidelines. So there are going to be 2 guidelines, one for adapters and one for application cases. So 2 separate lists. These lists, we have printed out. So in this printout, you have 2 lists that are pinned together, and they're also on the website. And the idea is that we're going to slowly work on them and update them. And on the website, you will always find the newest information, right? So the printout that you have is also just a printout of the website. And you saw that they're organized in quality levels. So you want to have a low entry barrier, so that you're ready, maybe your application case, you try to refactor a little bit, and then you get to something that we call bronze level. And then, yeah, what we want to do is that we want to like, yeah, hand out or organize such batches. That you could say, okay, I have this data repository, there is my my application case, and it is, yeah, it has bronze level of, yeah, precise conforming. Okay. And then, well, the idea is that who hands out these badges, so we do this together. The idea is that we have some kind of a review process. So you submit an adapter or a case. We still have to clarify what technically means to submit, but you could just tell us, okay, I have this application case. And then we're going to look at it, we're going to review it, and we're going to give you feedback. And the idea is that we work together to improve the quality of your adapter or your application case. And yeah, and in the end, we want to render like all of the cases, all of the adapters that are conforming on the precise website. So yeah, later in the work cafe, just after the coffee break, we want to discuss about these things. And there will be different topics, and already I write down here where we're going to discuss about this. So this review process should be one of the topics that we discuss later about. I think this is the one that Benny will do. So how could we like technically do this? What would you expect here? When would you think that you could first submit something to us? Yeah, all of these things we can discuss at the table with Benny later. Yeah, and then the idea would be to have something like this on the website. So this is now for adapters. For application cases, it would be pretty similar. So we would have like these, like such cards at the website where we have different adapters. You would see here what quality level they have, and there would be a lot of meta information. So yeah, maybe this is your solver. So who maintains it? What kind of license does it have? What kind of adapter type? Where can we find the source code? Where can we find the documentation, and how can you cite it? Right, and then you could go, you can click on more information, and then you would see the complete guidelines with answers to all of these different points. Okay, so this would be a bit the hope, right? So we will start slowly, but maybe in 3-4 years we'll have like a nice list, and yeah, hopefully some of the adapters we got to know today will end up here. Okay, and yeah, what is the timeline of it? So today we are at the workshop 24. So the idea, what we also promised in the proposal, is we're gonna present and discuss the first drafts. So this is really what we call like version 0.1 of these two guidelines. And we want to get your feedback today already to improve them and to learn what is missing. And then the idea is that there will be a phase till the next workshop in 1 year where we want to continue the discussion in the forum. So this is especially for the people that are not here today. So in the forum there will be, there are already now 2 threads about the guidelines. And we want to encourage you to also give us feedback there, saying, okay, this one point I cannot live with because with my adapter this does not work. And then slowly we want to like update the guidelines and release during that year updated versions. And then we come to the workshop in 25, and then the idea would be, we want to finally agree on like a version 1.0, that we say, okay, this is now our standards that as a community we defined. And also at the workshop we want to start training you on the tools that we develop. And then until the next workshop we want to slowly set up this review process and the things on the website to then implement like the standardization. Okay, and then on the workshop in 26, we want to train you on the standards. Okay, so how this timeline works, and especially how, for example, we could organize this discussion in the forum, and also how we could organize like this agreement at the next workshop. And this is also something we have not yet fixed completely. So there we also want your feedback and how you would expect this. Okay, do we want like a majority vote there, or does everybody need to agree, or yeah, how we could do something like this. Okay, now comes a very important slide. What is in this for me? So why should you do this? So there are many points. I think that the most important ones that we think why you should do this. Okay, so we are convinced that if we do this, that your adapters and your application cases will get better already by reviewing them together. Then, of course, the standardization will bring, that's the big goal, interoperability, meaning that if you follow the standards with your application case, then in the end it would be very easy to swap, for example, your fluid solver, and then run the same application case with a different fluid solver. It maybe could read in the same configuration file for the adapter. It would exactly understand the field velocity. Right, so the idea is really that we fully get this interoperability. And at the same time, it also means that you have to document less, right? Because then you don't have to explain how your configuration works, because you just say, okay, I use the standard precise configuration, and which is documented somewhere already for everybody, and you don't have to, your own documentation should get much slimmer then if you follow the standards. Yeah, we hope that this could also be something that you could put in your research proposals, that if you write a new proposal, you could say, you want to provide all of your adapters and all of our application cases at least in level silver, okay? And then the reviewers could look at the website and see, okay, there are some standards, this has quality, they know what they're talking about. And okay, this is, if we go very far, this could also mean that we can include your adapters in your application cases into our CI, so in our testing framework. That would be very handy, because then we notice if we break something. Okay, maybe we develop some new coupling method, and we know that there was this one code that used subcycling a lot and was relying on waveform relaxation. Okay, let's run these cases again to see that with a pull request we don't break that feature. Yeah, and of course we hope that this will improve the visibility of your work as well. Right, you developed an adapter, then everybody from the community quickly sees, okay, there is this adapter, and this is how I can cite it, so I can use it, and then I cite it. Yeah, so your work, and the other way around, it should also become easier that you use the work of others. Okay, so maybe there are more points, and maybe you don't agree with all of these points. So this is discussion topic number 6, which Marcus does, right? Okay. So you can tell him which of these points are more important to you, or maybe we forgot something. Okay, so now let's briefly look into these guidelines that we already drafted, and we organized them a bit with an overall idea. And the overall idea is, we want to follow the fairness. So these are these fair guiding principles for scientific data management and stewardship. So you maybe heard about this paper. So this was in 2016. An important paper where they first tried to write up these FAIR guidelines. And there's also one on research software that came a few years later. So this is more focusing on data, and then there's one more focusing on software. And in the end, FAIR means findable, accessible, interoperable, and reusable. And we now want to go step by step because we think there's some kind of a hierarchy in these. So pros means that your adapter or your application case is findable and accessible. So meaning that it is somewhere, it is working, and it is documented how to run it or how to use it. Silver means interoperable. So now it's meaning that it's standardized so that it plays well with other cases or other adapters from the community. And gold is that it's really reusable and also meaning integrated. So that, for example, we can test it in our system tests. Okay, so now let's have a very glimpse into the guidelines, just to give you some examples. Hopefully you read them already, but to give you some impression. And these guidelines will also be discussed at tables. So the guidelines for application cases will be discussed at topic number 1. So this Kame will do later. Yes. So for example, for bronze level, we expect or we want that all coupled solvers are available. So either in the open or commercially, but not like an in-house tool that you can just not access. And that there is a README file where you explain like the background, how to build it, how to run it, how to check. Silver would then be that you follow like a standardized structure of the case. So like that each participant is a different subfolder, for example, and how the precise config should be named, and that all the names in the precise configuration file follows a certain standard, so that you, for example, write velocity and not u. And in gold level, it would mean that the case is ready to be integrated in the system tests, and that the case either includes or links to full results, so that the people can really check one-to-one whether it is reproducible. And similarly for the adapters, so this is also a topic. So this one will be the table that Ishan moderates. So the here in bronze, we expect that the adapter is accompanied at least with one application case to test it. That there's again a README with background, how to build, how to configure, how to run the test case. In silver, we would expect that you have an adapter configuration, and this configuration at least covers the mesh name, data names, the participant name, the name of the precise configuration file, and for example, that there is a changelog. And in gold, we would expect that there are contribution guidelines so that others can extend your adapter, and that the configuration file really follows a formally defined schema. What is that? So typically an adapter has a configuration file. So this could be something like a JSON file here, where these are the typical things that you need to define. So for example, you need to say what is the participant name, where is the config, the precise config, and what kind of meshes am I using. And maybe you know what a schema is, maybe this is the first time you hear it. So a schema is basically a rule set that defines how such a configuration file should look like. And why does this help? Right, so if we have this, it enables interoperability. So then you could use the same adapter config file, but with a different adapter, and it should still work. It simplifies auto-generation. So we can, in the end, generate such files for you. And it enables tooling support. So just to give you 2 examples. So tooling support could mean that if you have like a text-like editor, and then you forgot to define the precise config, then the text editor could say, okay, you have an error here, you need to specify the precise config. So this could be, so this is a screenshot from a tool that this meta configurator tool that Marcus already mentioned. But this could also be like a plugin to VS Code, right? And then if you write your adapter config there, it could also complain. And you could also imagine that you have a GUI, and in the GUI, for example, you could define like tooltips if you hover over, or you could define like default values, and then it's just much quicker and much clearer how to write such a file. Okay, and all of this you can do as soon as you have a schema. Okay, so there's also a discussion topic on the schema. So this Felix will do. Felix is very new to Precise, but he's an expert in schema and configurations. So please be easy on him with Precise details, but you can ask him a lot what schema is, and he will also he will tell you what this meta configurator tool is and how we could work with this. Yeah. All right. So that's it with the main content. So now we want to discuss about this. Yeah, I think I'm still good in time. So next, there will be a coffee break to digest what you now heard. Then after the coffee break, we're gonna do the World Cafe. I'm gonna tell you on the next slide how this works. Now important things afterwards. After the World Cafe, we want to do the photo. So in the World Cafe, there will be different rounds, and after each round, there will be a bell telling you, okay, the round is over. And if you hear the last bell, this means then we will all, I guess, go out, or depending on the rain, and try to take a picture together. Okay, so please don't run away. And then after the picture, we will directly move over to the poster session. So the poster session will be outside here. We will distribute the posters a bit, and there will also be refreshments. So the idea is that we take this time to discuss at the posters or with each other and have a beer while doing this. Okay, so now about this World Cafe. So a World Cafe is a discussion format that we have not invented, that many people do, and I think maybe we're also not following all the World Cafe rules exactly. So we have kind of made it our own thing. So if you have been to a previous Precise workshop, you know the concept. If not, let me repeat. So we will have 6 tables. Each table will have one topic, one fixed moderator, and one or multiple sheets of paper to take notes. And then we will have 5 rounds of 15 minutes. So, and there will be a bell that rings after each 15 minutes. That means you cannot go to every table. So this is more a time issue that we had. But I think it's also not important. So you go to the topics that you're more interested in. And how this works is, we always did this with kind of a random walk, and we'll try this again. So there's not like a fixed order how you rotate. So you just go to the next table, and you try to, if we split evenly, it should be something like 4 to 7 persons per table. If there are already 10, then maybe go to a different table. If you see a table where there's nobody, go to the table. Normally this works out in a chaotic but in a smooth way. Okay, so just to remind you, so these are the 6 topics. There will be, I think the first 2 are pretty obvious. So this is the application case guidelines. So really the points that we have written down. Do you agree with these points? Should we add more? Should we remove something? So this will be Kame. Then the same for the adapters will be Ishan. Then this specific point of the adapter, this adapter configuration schema, this will be Felix. how we do this discussion and decision process, this I will do. How we do once we have the guidelines agreed upon, how we will then do the review process. This is Benny. And what is the added value of this for you, or there's not. And this Marcus moderates. And yeah, we will have 6 tables. There will be 1 table out here, 1 table out there, 1 table at the couch, right? So these are 3 outside, and the other 3 we're gonna have inside. So we're gonna do different corners here. Yeah, Ishan.
Yes, for that we would appreciate if everyone clears their laptop, because we will rearrange the room a bit after this talk.
Okay, yeah, that'd be nice. Okay, and we have not yet figured out who is where is where. But yeah, as you anyway random walk to the next table, it will also make no difference. All right. Before that, thanks for listening, and do you have questions right now?
So, any questions? Who was first?
I was just wondering, is there any material on, like, so to say, best practice of general adapter design? Or how do you would like mix this with something like adapter design patterns? For example, for some solvers you cannot really do the implicit coupling because just how the solver is written. So this would be interesting.
Yeah, we don't have something like this already, but this is also something that we want to develop. So the goal would be in the next years at the course to also have like a module on how to develop an adapter. And of course, yeah, there will be difficult topics, yeah.
So at one point you mentioned that you would test if it runs with a different adapter. And I didn't get what you mean by if it runs with a different adapter. Is it like if you have FSI, if you change your solid kind of solver and its adapter, or do you plan on having different adapters for the same solver, like having an open foam adapter? So what exactly do you mean by that?
So basically to get where we are with the tutorials already. So in the tutorials we have the perpendicular flap, and then you have a number of fluid solvers and a number of solid solvers, and you can combine any fluid solver with any solid solver. And you can decide this at runtime even. They all use the same precice-config. Yeah. But this is not the case yet with what everybody develops in the community.
Yeah, exactly.
So what I would want to do is, for example, this fire structure problem, that I could go and replace the fluid code that you use with maybe some open foam fire code, fire foam.
Yeah, but as more specific the solvers become, like as more community type solvers you get, as less likely it becomes that you can exchange it. Like
yeah.
you may take ISSM for an ice sheet model, and then you get an Elma adapter and you may use Elma ice, but that's it maybe, because the rest of the community may not develop.
Yeah, it depends on the application, of course. But for example, in your community, this will be the goal, for example, right? So that if there is at some point an Elmer ice adapter, that they would call the same variable with exactly the same name in the adapter as you are doing, so that we could use the same precice-config with them or with ISSM.
But that means that the different community codes are adjusting to a standard, which sounds not that feasible to me.
No, the adapters are conforming to a standard. So you can still use in your code a very different name, but in the adapter you would call the velocity exactly velocity with an uppercase V and no plural, for example.
Okay.
But I think iSheet modeling is maybe one of the harder cases here, right? I think with the FSI cases we are closer to that, right?
Yeah, exactly. It feels to me like there are kind of applications where you are very close to this plan, but what is your intention? Like, because you are giving levels with it, yeah? Is your intention to attract communities to sit together to develop standardization for a precise adapter? And if there isn't any, kind of then their fault? It's not. It doesn't sound very inclusive to me, but that's probably something for which table to discuss too.
Yeah, that would be the
Table
table
5
2.
or so.
Yeah, table 2 or table 6. You can also mention it.
Isn't it part of the review process in table 5?
Just to clarify this again, topic 4 will be what happens till next year. So how can we all agree on this process? And table 5 will be, once we agreed on the process, how could then this review process look like?
Mm-hmm. Okay. Well, then it's 2, 4, and 6. Right? If you want to would want to discuss this.
Yeah, there is some overlap between the topics, so it's no harm to bring up your point multiple times. Yeah.
So we are already aware of, sometimes you cannot do everything just because the software is has some limitations, and we want actually your feedback on. We are already setting some restrictions, right? Some standards that you then come from a different community and say, hey, in our perspective, in our community, this is just not feasible, and this is really the moment we need to understand what are we over-restricting, for example. And then we need a better way to express these guidelines so that in the end we give the possibility for everyone to achieve quality standards based on the baseline they are starting from and the context they are in. In the end, if in your community one feature is not used at all, then there's no point in asking it, right?
Yeah, so sometimes one thing we have in mind is it should be possible for every code and application case to go to level gold. It should not be that this is restricted somehow, right? So it's more about documenting which features you use than really implementing all features.
Okay, any more questions?
So I am actually not aware of how structured adapter should look like, because till now I haven't looked at any of the old adapters like OpenFOAM or something like that. So you asked me, if I could create something for FTS, but the problem with FTS is they keep updating every year. So they have more features coming into the versions, so which means sometimes they also restructure the complete layout of the programming code. Sometimes they have a structure of arrays, but next time you see it is split into 2. So in that case, as of now, we are using only one version, and I am sticking to that version. So before that, I was not using Precise, but I was using some other implementation. So in the later part, I found out that it is getting harder with more implementation that I make to adapt the new code to the things that I want. So even if I create an adapter, I know that the adapter also will undergo revision as the software is also getting upgraded. But the revision, it should be easier in my perspective, because if there is already a base adapter, then it should be just some data that has to be changed or added. It's not like it has the adapter has to be remade from the scratch. So how do you plan to address this kind of scenarios?
Yeah, so the guidelines are not really about you should have this class hierarchy in your adapter, right? It's more that we have like standards on how you configure your adapter, okay, so that if I look at your adapter configuration file, that I immediately know what all of these things mean, right? Because you're using the same names.
Yeah.
Or that, you clearly document. So there is a standardized way that you can document, does my adapter support implicit coupling, yes or no? Okay. So there, you can imagine that there is like a curated list, which you then would tick, and then everybody on the website could directly see, okay, this adapter supports implicit coupling, yes or no? Okay. More things like this. Yeah.
So it would be like reasonable to summarize it in that like the standardization would be a way that you could kind of look at the standardized output, let's say the cards, and then you could build the config XML basically just on the cards, because you'd know exactly what the config capabilities of that adapter were. Is that like understanding the correctly?
That would be one part, right? So if we have a schema for an adapter config, we could auto-generate adapter configs.
Right. And then you could just look at that and then know exactly what to put in the precise config file.
Yes, that as well. So we want to develop in preECO in the end a tool that generates all of this, so that you could have a GUI where you say fluid solid, and then you connect it with a line, and then you could click on generate, and you get out your adapter configs and your precise config.
Okay.
That would be a bit the vision.
Oh.
So something like the config visualizer, but in a reverse way, and a bit easier to handle.
Okay, I think we could do one more question, but this is not a must. So if there's something urgent otherwise. Okay, then let's close this session and get ready for the coffee break, and afterwards the World Cafe. And please don't forget to remove your notebooks from the tables.